We are live with Little Shop of Physics Live. It's 10:30, and this is Friday, February 12th, and this is a show about sinking and floating. And we have a slightly different cast of characters today. Over to my right is Brenna.
Hello, everybody.
And over to my left is Casey.
Hey, everyone.
And I'm Brian. And we have a whole bunch of things for you folks about sinking and floating. And we're going to do things a little bit differently than we usually do. And we're going to start with some theory and kind of like teach you something about density and buoyancy. So I have right here, I have a bowling ball, and I have it connected to a spring scale. So if I lift up that spring scale and look at the reading on it, I'm seeing the weight of this bowling ball is about 14 pounds. It's about 14 pounds. Now I'm going to take this bowling ball and I'm going to take it and dip it in the water. Now, when I dip it in the water, I see two things happen. One thing is the level of the water goes up. And we say the bowling ball is displacing the water. Like when the bowling ball goes in, it pushes the water aside. The other thing that happens is that the reading on the scale goes down. Now it's only reading about 3 pounds. So it's reading about 3 pounds. And the reason it's weighing about 3 pounds is this. I got a 14-pound bowling ball. And when I put it in the water, you can see it's pushing the water aside because the water level goes up. And it's pushing aside about 11 pounds of water. And that makes an upward force on the ball. And the upward force on the ball is about 11 pounds. And we call that the buoyant force. And whenever anything is submerged in water, there's a buoyant force on it. Whenever anything is submerged in any fluid, including air, there's a buoyant force because it's pushing some of that fluid aside. Now, I have another bowling ball right here, and this bowling ball I used was a 14-pounder. This one's an 8-pounder. This one's an 8-pound bowling ball. And I have a question. I'm going to take that 8-pound bowling ball, and it's exactly the same size as the 14-pound bowling ball. I'm going to put it in the water, and my question is this. Will it sink or will it float? What do y'all think? I want folks to weigh in and tell me, is this one going to sink or is it going to float? Ooh. Man, it's running neck and neck here. Hang on a second. There's been a sudden surge. Float is pulling out ahead. But no, it's a rally for sink. Oh my gosh. Nope. Float is back in front. So I would say about 2/3 of the people say it's going to float, and about 1/3 of the people says it's going to sink. And when we have a question like this, the only way to figure out the answer, of course, is just to try it. So I have an 8-pound bowling ball, and if I take it and put it in the water, it floats, which is kind of amazing. I mean, don't think about bowling balls as being something that's floaty, but this is a floaty bowling ball.
I like the noise that made.
It makes a little glug when the holes go down, and it floats holes down, which is kind of awesome. If I take this and push it all the way under the water, there's a buoyant force on it, and the buoyant force on it is 11 pounds. But the ball only weighs 8 pounds, so there's a net upward force, and if I let go, it pops up. And it also gets water all over my trousers, which is kind of awesome. So, thank you for laughing at that. I appreciate that very much. So, that's the way that sinking and floating works. This ball displaces a greater weight of water than its own weight. And so it's going to float. And another way we can view it is we can say it's got a lower density, because a bowling ball-sized chunk of water weighs 11 pounds. A bowling ball-sized chunk of bowling ball weighs 8 pounds. And so it's pushing aside a more dense fluid, and so it's going to float. How about a basketball? I think we know what's going to happen here. The basketball is much, much less dense than the bowling ball. And so if I take that, it kind of just rests on the surface of the water. It floats very, very handily, because it's almost the same size as the bowling ball, but weighs quite a bit less. And if I push this underwater and let it go, this is going to be good. And this is definitely all the way out. I got to do that one more time. That's kind of awesome. All the way under the water, and there's a huge upward force on this thing. And if I take it and let it go, the ball comes right out. It's tossed up to me, and a lot of water. So while we do our next thing, I'm just going to gently kind of clean things up. So that's the basic idea behind the sinking and the floating. And over here, Casey's got kind of a container of fog. Casey, tell us what's going on over here.
All right, Brian. So right here I just have a humidifier, which we've put just half of a pretzel container over top so it can catch some of this fog that's coming out.
And what is fog made of?
And fog is just air that has a lot of water in it, which is making it cloudy like this and sink towards the bottom of the container.
So if it's sinking towards the bottom, sounds to me like it's more dense. So if I have air with water in it, it's more dense than just plain old air.
Right. And here I have a little bubble blowing machine. And if I dip it in this bubble
And that looks like
fluid,
a handmade bubble machine
Looks like
right
a
there.
torture device.
What's that?
It looks like some sort of torture device.
It does look like...
But if I blow this bubble up with air, there's no water in it like this fog. See if I can get it to land in there.
Oh my gosh.
Oh, hold on. It might take me a minute to get the placement right.
So Casey's going to blow a bubble, and the bubble's filled with air, but the fog is more dense. Whoa.
That one, oh, did it disappear?
We lost her.
We
Hold
lost
on.
it? Okay.
Man.
Let me try another. Little finicky.
Blowing a bubble in the fog.
Whoa! I saw it sink, though.
Did you?
Yeah.
Sorry, this is real hard to get.
It's slightly finicky. That's okay. That's okay.
Oh, my goodness. Try one more time.
One more time, and if not, we'll cut to a video, because we got this on video. Okay, one more shot. Here it comes. Bubble and... yeah, let's cut to the video and see. So here's Casey doing this in the studio. Same story. Container of fog. And if we blow a bubble, check it out. It lands and it bounces on the fog, because the bubble is less dense than the fog.
And why doesn't the bubble pop, Brian?
Well, that is a fine question. The enemy of bubbles is drying out, and it's sitting in a bath of fog. You got one? Awesome. There they are, bubbles in the fog, and they will live forever. We call this bubbletopia, because the bubbles will like last a long, long, long time, which is kind of an awesome, awesome thing. Now, Brenna has a tank behind her that looks like it's filled with air, but I think it's something else. Brenna, what's going on back here?
Well, here I have a big tank, and it is full of dry ice, which is solid carbon dioxide. And as we saw from a few episodes ago, when we filled a balloon with carbon dioxide, it sank really fast, and it was heavier than regular air. So, what that means is that it's more dense than regular air. So if I fill up a balloon with regular air, you think that's full enough, Brian?
Oh yeah, that's going to work.
Alrighty. I can actually float it on top of the CO2 that is in this tank. So, I'm not lying to you guys. This is just a regular balloon full of air. But if I put it in here,
whoa!
it floats!
Whoa!
It's because the air in the balloon is less dense than the CO2 that comes off of that dry ice.
That's amazing. It's just floating on a dense layer of gas in the bottom of that tank. That is... Oh yeah, and you're going to put in a second balloon, I hope. Awesome. Yeah, we need more of this.
Alrighty, and if I put another one in there, so that one has a friend.
That's good. It's just like hamsters. I think balloons need to have friends
yes,
too.
They do need friends. They do need friends.
Oh my gosh, that one's floating really high up. Oh, you know what's happened? That yellow balloon went down lower. You know what I think? I think it got chilly, and if it gets chilly,
it sinks as well.
It gets more, the gas gets less dense, and it gets sinky.
So if
Let's see
I
if
take
the blue balloon does that. Oh yeah, look.
Warm it up a little bit. Put it back in.
Warm it up a little bit.
Let's see.
Oh, it's still, that thing is chilly.
It's still sinky. That's okay.
That's okay.
It's all
Let's
good.
let him stay there for the time of this session, and let's see what happens to him.
All right.
Because the blue one is definitely floating at the top, but I bet it's going to go lower. That's what I'm betting. I'm betting it's going to get colder.
I bet.
And when it gets colder, it's going to get more dense. Oh, it's like a hot air balloon. It's like the opposite. This is a cold air balloon, which is why people don't fly them.
Yeah, it would be kind of sad.
It would be sad. Come for a cold air balloon ride.
So fun.
Now I've got right here a container of a very, very dense liquid. Okay, very, very dense liquid. And this one right here is filled with mercury. And mercury is very, very dense. It's 13 times as dense as water. And in the bottom of the mercury container, there's a little steel nut. And I'm holding it in place with a magnet. And I'm going to remove the magnet. And you can watch this nut. It's just going to pop to the surface.
Whoa.
There it goes. and that is a piece of steel. And you can see because I've attracted it to the magnet, and I make it sink all the way to the bottom. Oh, sink to the bottom. Then when I take away the magnet, it floats. So this liquid is very, very dense, more dense than steel. And this container is surprisingly heavy. We were sharing it around the shop on Tuesday, and people couldn't believe how heavy it was. It's crazy how heavy that is. Now, Casey's got an experiment. You got a couple of different liquids going on in that container.
I do. So here, Brian, I have a glass jar filled with water and kerosene. And if you've ever made salad dressing with oil and...
With kerosene?
You're probably not with kerosene, but with oil.
Don't make it with kerosene. But it's the same concept, how the oil floats to the top because it is less dense than the water. And I've got a bunch of different objects here, and we can see where they float in this if you'd
Awesome.
like.
Let's do it.
So I have a balloon filled with air. Floats.
Right on the top.
Floats. And here I have just a piece of a balloon, not filled with air. See where it goes.
Oh, wait, it floats right on the top.
Oh, there it goes.
Oh, wait, hang on.
Now it doesn't have...
Well, it just kind of hangs out right there.
Hangs out in
right
the middle.
in the middle. You can see that a little better. I've got a plastic die.
Oh, and that one, that's bound for the bottom.
Let's see. And a paper towel.
Hmm.
And there it goes. Joining that balloon in the middle.
Oh,
It's
yeah,
just
it
going
is.
to lay on it.
I have a piece of a plastic straw.
Oh,
And
that's
it's
right
right
at
in
the
the
middle,
middle
too.
too. And then one last thing to try. I have a slinky. It might land on the other stuff.
Oh,
Nope.
man, the slinky, that's bound for the bottom.
Oh, yeah.
And it took some things down with it. Now, this looks like something people could try at home, doesn't it?
Yeah, this is actually how a lot of recycling companies sort their plastics. If you cut them up in little pieces, and they float in the different parts of liquids because they're made of different materials.
Oh, so and the different materials have different densities, and so they sink and float in the different liquids.
Yes.
Brilliant. Brilliant. Now, Brenna has chickens, and
I
chickens
do.
lay eggs, and we
I
got a little egg
do.
experiment going on here.
Yeah, so if you ever have had eggs and you're wondering if they're have gone bad, if they've been in your fridge for a very long time, you can actually check. And this is kind of a farmer's hack, if you will. And I used to live out in the middle of nowhere, so I've always had chickens, and this is how we check our eggs. So here I have some eggs that Brian said have been in his fridge since September, which they're really old.
They're probably were fresher in
Yeah.
September than they are now.
Yeah, if I put this egg in the water, it floats. And this means that this is a bad egg because eggs absorb gas from the environment and they become
Ooh.
less dense. Now, I have eggs fresh out the chicken. I got them from my own chickens at home. If I put a fresh egg in the water, it sinks because it's more dense than the water right now because it has less air inside. So this is how you can check if your eggs are still good. If they float, don't eat it. If it sinks, you can eat it.
So Brenna has just saved me from potential food poisoning here. So Brenna, thank you for that.
Yes, I have. But I can actually make a good egg float. So if I take some water, and this is just kind of warm water, and you'll see why in a second, and I put a good egg in there, it sinks.
And so
like
that
it
egg
should.
is more dense than the water.
Like it should. But if I put salt in water, it actually makes the water more dense. So this egg can float, and you can actually see it starting to
Oh, yeah.
float around in there. Let's see. Ooh, maybe I need some more salt. There it goes. And look at that. That egg
Wow.
has rose to the top.
Oh, yeah, there it is.
Yep. And
So you took a good egg and you made it floaty.
I did. And it's still a good egg, but it's
still a
in
good egg.
salty water.
But salty
So,
water.
yep.
Oh, yeah. So you just increased the density of the fluid, and that made it float. That is awesome. And the thing that makes the bad egg float is gas in it. Like if you open up that egg, there's definitely a gas pocket inside there. And there's diffusion, like liquid goes out, gases go in for a not so fresh egg. And there's other things. If you have air in them, makes them floaty. And Casey's got a little something.
So I've got just a regular old bar of ivory soap here, which appears like it'd be pretty solid, pretty dense, right? But put it in some water and it floats.
It's quite floaty.
Yeah, I guess it has a lot of hidden air pockets in there.
Yeah, so they put a lot of air in. I remember when I was a kid, we used to use ivory soap in the bathtub.
I was going to say, you'll never lose your soap in the
Soap. It
bathtub.
was just floating right there. And we made little boats. We would put little sails on them. It was kind of awesome. All right. And then speaking of chickens, we're back to Brenna here. Brenna has chickens. And we were trying to come up with an animal example of animals that sink and animals that float.
Yes, we were. And turns out that, well, most birds can fly. Chickens can actually fly, but they're not very good at it. But all birds, pretty much all birds, have hollow bones or porous bones, which means that they are pretty buoyant in water.
They're pretty low density.
Yeah, so I have a video where I took some chickens out of my mom and I's chicken coop, and we ran them a little bath. We even gave them a bath bomb.
This is like chicken spa day.
It was. And there they are, just hanging out. We got a big one and a little one. And they just kind of, they just chill in there.
They're just chilling in the water, just floating.
And the little one you can really see. She floats good, so.
That is awesome. That is awesome. So chickens float. Now, that's kind of crazy because like chickens don't necessarily live near the water, but they're creatures that do live near water that actually sink. And we don't have an actual animal. We have a little animal figure over here.
No hippos on deck here. But this hippo, he's made of wood.
But it's really dense wood.
Really dense wood. And if you put him in water, lower him down.
Because you would think if it's made of wood, it would float.
You would, yeah.
Just like I would think a hippo would float.
Yeah, because you always see their heads poking up above the water. But as it turns out, they are actually just running along the bottom of the river?
Yeah, rivers and lakes.
Or, I don't know.
Or fish tanks. You can
Yes.
make this little hippo run along the bottom. There it goes, run
There
along the
he
bottom.
goes.
And that's what hippos don't swim. They just run on the bottom, those little rascals.
Oh, yeah. They're massive.
Just walking your hippo. It's
Walking
fine.
the hippo. That is awesome. Next, we're going to talk about the connection of buoyancy to gravity. And here's the interesting thing. Like when we started out here, I put a bowling ball in the water, and it pushed the water aside, and the water wants to come back. And when the water wants to come back, that's what's making that buoyant force. But for that to happen, you have to have gravity. I'm going to show you a container here. We have this container, and it's got one of these little ducks that we like. I think.
That's my duck that was getting married. You
Oh,
stole her.
I'm sorry. It took a break from getting married,
Oh,
and
my
now it's doing a little
goodness.
physics experiment. It's a little peppermint duck here. And you can see it's floating. There's a buoyant force pushing up on it, but it's actually under the water, and it's being held down by a spring. And so there's a spring force pulling down, and there's a buoyant force pushing up. And right now those forces are in balance, and so the duck is just chilling in the center of the container. Now, if we took this container and dropped it, what happens is it's as if we've turned off gravity, okay? And if we turn off gravity, I want you to think about which way the duck is going to go. Is it going to go upward to the surface? Or will it get yanked down towards the bottom of the container? And I'm going to go ahead and put up a poll and tell me what you think will happen. Ooh, man, and we're getting distinct. People are saying up towards the top of the container. They're saying up towards the top of the container. I think we better show a video to see what happens. And we made something in the shop the other day. We made a little video. And we have this container with the little duck on the spring in it. And then Emma dropped it, and Emma got, oh my gosh, look at it go. Look at it go. That duck is bound for the bottom. And Emma was not happy about the splash. But watch it go. There it goes. It gets pulled smartly toward the bottom of the container.
Is this because the water doesn't have any gravity acting on it either?
It's kind of like if we turned off gravity, the duck is pushing aside water, and the water wants to get back, but it wants to get back because of gravity. But if I could turn off gravity, I turn off buoyancy. So no gravity, no sinking, no floating. Everything just kind of chills. So I turned off the buoyant force, but you kept the spring force, and the spring just pulls it to the bottom, which is kind of a cool thing. And we did another thing where we took a fish tank and we rolled it back and forth, and this is kind of an interesting physics thing. When you accelerate the tank, the floating duck actually moves in the direction of your push. So when Maud rolls it forward, it doesn't kind of like stay put. It moves in the direction of the push, which is kind of amazing. And something you can try on your own like this is helium balloons. If you take a helium balloon in the car and the car turns a corner, the helium balloon goes towards the inside of the curve, which is kind of cool. And that's sort of a subtle physicsy thing, but this is for my peeps right here. This is the kind of stuff my peeps just love to pieces.
Well, and that is the husband duck. So
the two ducks just went and had a little kind of like...
They were working.
They're working. They had an experience. There'll be time for the matrimony kind of like shortly. We'll come back to that. Don't worry. Now, the whole reason we do this little shop of Physics Live is we want to get people intrigued and excited about science. And we want to give you some things that you can try at home. So we have a whole bunch of sinking and floating things that people could try on their own. Over to Brenna.
Yep. So I have a fish tank, but you can use, this is just so you guys can see, but you can use any sort of clear container. And I have a regular unpeeled orange. I have a peeled orange. And then I have this orange with a little bit of the peel left on. And it turns out that depending on whether these oranges have the peel or not, they are more or less buoyant. So the unpeeled orange is pretty buoyant. It floats at the top. The peeled orange is less buoyant. It just sinks to the bottom. And this one with a little bit of the peel on, you can see it's kind of starting to float a little bit because that peel contains a lot of air, makes these things less dense and thus less buoyant, which is kind of awesome.
So that's how I could tell if my oranges are peeled or not.
I hope you would be able to.
So go to the fridge and just start throwing stuff in the water.
Oh,
is what
yeah.
I'm saying. Just see what it
Parents will be
teaches you.
very happy with you.
And then Casey has got a little, you're going to do a little craft project for us. It looks like.
Yes. So here I have some little melted down aluminum foil beads our friend gave us. And if you put them in the water, you can see with the hippo, they sink right to the bottom because they're so dense. There's no air in those. They've just been melted down all the way. But I can show you here. I have just some aluminum foil. Get it from your kitchen. I cut out a square, and then if you can see, I cutted 2 little slits, or 4 little slits, I guess, 2 at the top and 2 at the bottom. You can take it and just, let me see if I can fold it here. Fold it into any kind of boat. Anything that looks like a boat will work.
Oh, I see.
I'll show you how I do it here. I'm just going to fold in all of the longer sides first, and then fold over the ends and just pinch it down so it doesn't go anywhere. Okay? I'll even put little Pashmina in here. She's our hamster friend.
Oh, nice. I'm glad that Pashmina gets to come back again.
And there you go.
All right. And so aluminum sinks, you proved that. But when you make a boat out of it, it floats. It
floats. Yeah, you just have to make it a little less dense, get some air in there, and
so
it'll float.
It's basically a giant bubble in the center of the boat.
Right.
And it's the bubble that is awesome. So you can make a boat out of something which is sinky. And then Brenna has got a little, we had some desiccated trail mix where
Yes,
we rescued some raisins from it.
These raisins have been in the vending machine downstairs of the little shop of physics for probably a year and a half. But anyway, I can make them, I can resurrect them, right? So here I have my seltzer, and you can use seltzer or you can use ginger ale or a clear soda like that. And if I pour it in here, it's all bubbly and fizzy. And it turns out that when I dump my raisins in here, they will sort of collect the bubbles from the seltzer, rise to the top, release those bubbles, and then they will sink back to the bottom. So here you kind of get these jumping raisins, and basically what they're doing is they're collecting air, becoming less dense, going to the top. Once they lose that air, they're more dense, they sink back to the bottom. Kind of awesome.
That's like a raisin mosh pit right there. That is awesome.
They're having a party.
That is fantastic.
They're having a party.
And then Casey has another sinking and floating thing. Oh my gosh, Casey, what do you got there?
All right, I've got another thing you guys can do at home. What I've got here is just a small trash bag that we've attached a pipe cleaner to, just on 4 points here. Taped it with some Scotch tape so it stays pretty light. And I can show you, you can make a hot air balloon out of it. Borrow your mom or dad's hair dryer. Let's see.
Whoa!
Oh, there it goes. There it goes.
Sometimes if you can fill it with enough hot air, they'll stay floating for a pretty good amount of time. So
Yeah, let's get it nice and toasty. We got time to make this go. So inside, nice and toasty. Let it go, and there it is, bound for the ceiling. Bound for the ceiling.
Yep.
And then when it cools off,
Sinks
back
back
comes
down.
back down, comes back down. Speaking of that, we're going to go over to Brenna, and behind Brenna is the balloons in the tank. How is the blue balloon doing? Is it riding lower?
I'm not sure. Let's see if we
If you push
poke it.
how about if you hold it down so it cools? Like get it in the cool stuff.
Let's see what happens. It's definitely cold because it's freezing the outside of my tank
Oh my
here.
gosh, and then if you let go, will it stay down? No?
No, it's
that-
really not wanting to.
It's going.
No, it's lower.
There it goes.
Little
It's
lower.
lower
Definitely
now.
lower. So when we cool it, it becomes more dense and becomes less floaty. Awesome.
Yes, it
Man,
does.
somebody's already got a plastic bag there. They're ready to go.
All you need is a hair
Yeah,
dryer.
is ready. This is awesome. People are ready to get the show on the road here. Now, another thing that Brenna has. Oh, you're still working with the balloon.
I was seeing it. It's getting lower. It's getting
Oh,
lower.
it's getting lower.
It is.
It's getting lower. So
It is.
making it colder. Oh, how about if we took it and heated it up with a hairdryer?
Oh, we could do that.
Let's take that yellow balloon. Yeah, the yellow balloon wants to float. I'm gonna.
All right,
throw
we're
it to
gonna
me.
socially distance pass a
Okay,
balloon.
socially distance balloon passing.
Heat this up.
Heat it up.
Let's
You
see
just
what
want me to.
happens.
Yeah, just hit that thing with a hairdryer. Get that thing warm. I've never used a hairdryer on a balloon before. This is a first for everything.
There's a first time for everything.
All right.
Little
I'm gonna
toasty?
little toasty. Pass it back to Brenna. Here it is.
Here we go.
Okay.
I feel like we're in a relay race.
In the container, and it
Oh,
flies.
Oh, and it's already sinking.
It's already
again, but
sinking.
fine.
That yellow balloon just cools off quickly.
Yeah.
That is awesome.
Yeah.
That is awesome. Okay, next, Brenna has got one last thing for us, and you got 2 different kinds of soda.
I do. I'm gonna make a root beer float. I am.
Oh.
So I have 2 different types of root beer. I have a diet or a sugar-free root beer, and then regular root beer. Okay? And if I put this regular root beer in here,
Man, that is bound for the bottom.
it sinks. And it sinks because it has a lot of sugar dissolved in there. And sugar is pretty dense. So it sinks to the bottom, just hangs out, won't come off the bottom. But if I have a sugar-free soda, it does not have as much sugar dissolved. It is not as dense. And thus, I can make a root beer float. So if you guys make a root beer float, you need diet soda
There
for it to
is.
be physically floaty.
Physically floating. That is awesome. And that is a kind of a nice indication of how much sugar is in there. That there's enough sugar to increase the density enough that actually
Yes,
sinks,
and how much
which is
sugar did
crazy.
you say is in there, Brian?
7 teaspoons.
Woo!
7 teaspoons of sugar. And you add 7
That's a
teaspoons of
lot.
sugar, that increases the density enough that thing becomes sinky. That is awesome. What I want to do is now talk about our next show. So what we've been doing today is we've been doing a little changing one variable, changing another variable, and seeing what you end up with. That's the process of doing science. And next week we have an episode called Science It Up. And we're going to take some questions from some students in the Poudre School District and say, how do we take this question and turn it into a scientific question? And then I will say, too, we're looking for schools that we can work with. So if your class has a topic or a question that you would like Little Shop of Physics Live team to consider, have your teacher reach out to us, and we would love to feature you on a future installment of Little Shop of Physics Live. We're going to say goodbye for today. I'm Brian.
I'm Brenna.
Casey?
And Casey over here. And behind the scenes, we got Adam and Patrick making all the tech work. Thank you all so much for joining us on this episode of Little Shop of Physics Live, and we will be back next week for an episode called Science It Up. We'll see you then.
Bye, everyone.
Bye.